Um, Hello. In this notebook, I'm demonstrating the TensorFlow built-in layers version of basic neural network for nonlinear regression. So, in this first markdown cell, I described the assignment goal. The task is to build the three hidden layer neural network for nonlinear regression using synthetic data with three input variables. The synthetic target equation is nonlinear, so a neural network is suitable for learning that mapping. And okay, let's start. In this first code cell, I install the required packages TensorFlow, Scikit-learn, and Matplotlib. TensorFlow is used to build and train the neural network. Scikit-learn is used for splitting the data, and PCA and Matplotlib is used for plotting. Next, in this section, I import a NumPy, Matplotlib, train, test, split, and NumPy, Matplotlib, and PCA. I set a fixed random seed for reproducibility. Then I define a make data function. This function creates a x1, x2, x3 data variables. These are like non-linear regression. Um, Sorry, this function kind of creates a synthetic nonlinear regression data using these three variables like x1, x2, and x3. The target y is generated from nonlinear equation involving sign of one variable, polynomial of terms, and interaction terms between variables. This makes the regression problem nonlinear instead of linear. Then I combine the three variables into a future matrix X and then reshape Y into a column vector. After that, I split the data into training set, validation set, and test set. The training set is used to fit the model, validation set is used to monitor performance during training, and the test set is used for final evaluation. I also print the data shapes to confirm everything is split correctly. In this cell, I create a 4D style plot of the dataset. Since there are three input features plus one target variable, the data can be viewed as a four dimensionals. And to visualize it, I use a PCA and reduce the input features into three principal component. And then I create a 3D scatter plot, PCA component 1 on x axis, PCA component 2 on y axis, and PCA component 3 on z axis. And the color of the each point represents the target value y. So this gives a 4D style visualization where position shows the transformed input features and color shows the output. This is the main model creation section. Here I import a TensorFlow and sets the TensorFlow random seed. Then I define neural network using a tf.keras.sequential. Inside the sequential model, I add an input layer with because there are input layer with shape 3 because there are three input features, and then I add a first dense layer with 32 neurons and a ReLU activation, then a second dense layer with 24 neurons and ReLU activation, third dense layer with 16 neurons and ReLU activation, final dense output layer with one neuron for regression. So this is a hidden layer neural network. After defining the model, I compile it using Adam optimizer, mean squared error loss, and mean absolute error as an extra metric. Since this is a regression problem, mean squared error is an appropriate loss function. Then I call model.summary to display the network architecture and the parameter count. As we can see, the different layers along with their output shape and parameters are given in this table. Next is model training. In this, I train the model using model.fit and I pass xtrain, ytrain as a training data, xval, yval for as a validation data. The model is trained for 250 epochs with a batch size of 64. I set verbose is equal to 0 to keep the notebook cleaner, and the training history is stored in the history object. And the history is useful because it stores the training loss and validation for every epoch. At the end, I print the confirming message saying that training is complete, and we can see once the training is completed, the message is print. And then in this section, I plot the loss curves. I use the history object to plot the training loss and validation loss. against the epoch number. This helped me to see whether the model is learning well. If the curves go down and stay reasonably close, that usually indicates healthy training and decent generalization. This plot is useful because it shows how network improves during training, not just a final output. In this cell, I define a helper function called regression report. This function calculates important regression metrics such as mean squared error and root mean squared error, or mean absolute error, and R squared. These metrics help evaluate how well the model predicts continuous target value. In the final section, I use the trained model to predict on the test set. The prediction are stored in the y test prediction. Then I call the regression report function to evaluate the final test performance of the TensorFlow built-in layer model. After that, I create a scatter plot comparing actual target value to the predicted target values. If the model performs well, the points should lie close to the ideal trend line. This gives visual confirmation that prediction quality on unseen test data. So, to conclude, this notebook demonstrates a nonlinear regression model built using TensorFlow built-in layers. So that's it with this one. Thank you.